Have you ever stood in awe, looking up at a massive wind turbine, its blades slicing silently through the air, and wondered how we got here? These giants of renewable energy feel so modern, so 21st century. But what if I told you their story is filled with forgotten giants, pioneering spirits, and one spectacular history-making failure? Today we're winding the clock back to the 1940s, to a windy mountaintop in Vermont, to uncover the incredible tale of the Grandpa's Knob wind turbine and the day it all went wrong. This isn't just a story about a machine breaking. It's the story of a lesson learned that powers the very turbines we see today. The year is 1941. The world is at war, and America is desperate for new sources of power. Fuel is being rationed for the war effort, and the need for homegrown energy is more critical than ever. Enter a visionary engineer named Palmer Smith-Putnam. He wasn't just an engineer. He was a sailor, an adventurer, who felt the power of the wind in his sails and dreamed of harnessing it on a grand scale. He believed wind could be a major player in the nation's energy grid. Most people thought he was crazy, a windmill to power a city. It sounded like science fiction, but Putnam was persuasive. He managed to assemble a dream team of engineers and secure funding from the S. Morgan Smith Company, a major manufacturer of hydroelectric turbines. Their ambitious goal? To build the world's first megawatt-class wind turbine, a machine powerful enough to feed electricity directly into the New England power grid. The location they chose was a 2,000-foot-high peak in central Vermont, known locally as Grandpa's Knob. The name was quaint, but the weather was anything but. This spot was notorious for its brutal hurricane-force winds, making it the perfect, albeit terrifying, testing ground for their creation. Over months of grueling work, the monumental structure took shape. This was no ordinary windmill. It was an absolute behemoth for its time. A 110-foot steel lattice tower was erected on the frozen summit. Atop it sat in a cell the size of a bus, housing the generator and gearbox. And then there were the blades. Two colossal stainless steel blades, each weighing 8 tons and stretching 175 feet from tip to tip. When the Smith-Putnam Wind Turbine, as it was officially known, was completed, it was a breathtaking sight, a symbol of human ingenuity against the raw power of nature. In October 1941, the moment of truth arrived. With engineers holding their breath, they flipped the switch. The giant blades began to turn, slowly at first, then picking up speed until they reached their operating rhythm. And it worked. For the first time in history, a wind turbine was successfully synchronized with a major electrical grid, delivering clean power to homes and businesses across Vermont. It was a monumental achievement. For the next few years, the turbine operated intermittently, feeding power into the grid and providing invaluable data. It proved Putnam's theory: wind power on a utility scale was not a fantasy. It was a reality. The engineers learned so much. They battled ice buildup on the blades in the harsh Vermont winters, a problem that still challenges turbine designers today. They tinkered with the pitch control systems, refining how the blades adjusted to changing wind speeds. The turbine was a living laboratory on a windy mountaintop. But the immense forces at play were pushing the limits of 1940s material science and engineering. The machine was under constant, incredible stress. Small cracks began to appear, bearings wore down faster than expected, and the project was a constant race to repair and reinforce. Then, in the early morning hours of March 26, 1945, the inevitable happened. After a long period of shutdown for repairs to a critical bearing, the turbine was finally back online. It had been running smoothly for a few hours when, without warning, a catastrophic failure occurred. One of the massive 8-ton steel blades, weakened by years of stress and the harsh environment, snapped off at its root. The immense piece of metal was hurled through the air, landing a staggering 750 feet away. The sudden, violent imbalance sent shockwaves through the entire structure. The remaining blade flailed wildly for a few terrifying moments before the automatic brakes kicked in, bringing the crippled giant to a shuddering halt. Standing on the mountaintop, the sight was devastating. The once proud symbol of the future was now a broken wreck. The dream, it seemed, was over. With the war ending, the economic incentives had changed. Repairing the turbine was deemed too expensive, especially when traditional fuel sources were becoming cheap and plentiful again. The S. Morgan Smith Company, having spent over $1 million a fortune at the time, decided to cut their losses. The great experiment on Grandpa's Knob was officially abandoned. The remaining structure was dismantled a few years later, leaving only the concrete foundations as a silent tombstone on the lonely peak. For decades, the story of the Smith-Putnam turbine was largely forgotten, written off as a noble but failed experiment. It looked like a dead end for large-scale wind power. But here's where the story takes its most important turn. The failure wasn't the end. It was the beginning of a crucial new chapter. The engineers meticulously documented every success, every challenge, and especially the catastrophic final failure. Their detailed analysis pointed to a critical flaw: metal fatigue. The constant flexing and stress on the blade root had created microscopic cracks that grew over time until the materials simply gave way. But their analysis also looked at the electrical systems. While the mechanical failure was the ultimate cause of death, the generator and its connection to the grid had been a remarkable success. The systems they designed to handle the fluctuating power output from the wind and safely synchronize it with the steady AC grid were groundbreaking. They proved that a variable source like wind could be reliably integrated. The data they collected on generator sizing, power conversion, and grid stability became the foundational text for the next generation of engineers. When the energy crisis of the 1970s reignited interest in renewable energy, scientists and engineers didn't have to start from scratch. They dusted off Putnam's reports. They studied the electrical successes and the mechanical failures of the Grandpa's Knob turbine. The lesson was clear. The blades and mechanical components needed to be much stronger and more flexible, but the fundamental concept of the generator and grid interface was sound. This knowledge directly influenced the design of the wind turbines that began to pop up in California and Denmark in the late 70s and 80s. They learned that generators needed to be more robust to handle the gusty, unpredictable nature of wind. They developed more sophisticated control systems, inspired by the early work on Grandpa's Knob, to protect the generator from power surges and mechanical stress. The failure of 1945 forced a shift in thinking. Instead of just building bigger, they had to build smarter and stronger. The generator designs that emerged were more resilient, more efficient, and better equipped to handle a lifetime of stress. So, the next time you see a wind farm, remember the ghost on Grandpa's Knob. It's a reminder that progress is often built on the lessons of failure. The spectacular end of that pioneering machine wasn't a tragedy for wind power. It was a necessary sacrifice, provided the critical knowledge, particularly about building stronger and more resilient generators, that allowed the dream of clean, wind-generated electricity to be reborn, stronger than ever before. The silent foundations in Vermont are a monument not to failure, but to the enduring power of a great idea. Thanks so much for watching. If you found this piece of forgotten history as fascinating as I do, be sure to hit that like button and subscribe for more stories about the engineering that shapes our world. Let me know in the comments what other historical tech stories you'd like to see covered. See you in the next video.